So, let us start the lecture number 11 of this module 2. In the previous lectures, we analyzed the converter circuit, and especially we saw the 6-pulse converter, both inverter as well as the rectifier operation, and also we saw this 2 3-valve conduction, 4 conduction modes. Now, I will just explain based on the derived equations how we can draw the converter chart, and now the question arises, why converter chart? By the help of converter chart, we can identify for a given set of voltage on this converter and the current what will be the required quantities. Or you are knowing any quantity, then you can go for the voltage and current correspondingly. For example, in any chart, suppose in this case I will be going for here the voltage, that is a DC voltage. Here I will be going for a DC current. So, in this, if we can draw the some set of curves for a constant value, then from that curve, for let us suppose this is a curve that is like this. So, this is some constant, let us suppose this is your alpha for a given value. So, for knowing this alpha, we can know what will be our VD and ID directly from this chart without evaluating the characteristic. So, this is one example just I am quoting. So, with the help of chart, we can get what is your voltage, what is your DC current for given value of this, or if this is and this is known and this is known, then you can find what will be the value of alpha. So, reverse is also true, means it avoids the calculation, and you know there is so sine, cos, etc. are there. So, directly knowing this value, you can find what is the actual operation mode of your converter circuit. Now, you can see we have the various variables in our derived equation, means we derived equation, if you remember, that is when u is less than 60 degree. We derive our equation here VD, which we will be using again in this lecture. Here it is your VDO by 2, here cos alpha plus your cos delta. This delta is nothing but your alpha plus u. We also derive our current here, it was your IS3 cos alpha minus cos delta. Here your VDO is nothing but 3 under root 3 EM divided by pi, and your IS3, it is your nothing but this is EM divided by 2 omega L. So, this is the case when u is less than 60 degree, or I can say here it is 2 to 3 valve conduction mode. We also derived for u is greater than 60 when your the conduction valve, that is 3 to 4 valve conduction mode, and here we derive our VD, it was your under root 3 by 2 VDO cos alpha prime plus your cos delta prime, and your ID was your under root 3 EM by 2 omega L. It was say no, it was not having root 3, and here it was cos alpha prime minus cos delta prime. So, from these equations we can see these are the equations your the DC side of your inverter or converter circuit, means the various variables we are having now. Here I can say alpha, delta, and we are having u, although here this delta depends upon these two. So, we can have the characteristic in terms of currents here VD as well as the voltage, we can have the 3 variables here. So, the DC side quantities which I have written here, it is we are having this alpha, delta and u on this are the two variables. So, our x axis will be your ID and your y axis will be your VD, and then we can, for a given constant value of alphas or constant value of delta or constant value of omega, here we can draw the characteristics. So, these are the simple equation, but only here difference, we are having the two modes, one is u is less than 60, we are having a different set of equations, and here if it is a x u is greater than 60, we are having the two different equation compared to the previous one. So, these are called the DC side variables, because we are controlling our converter circuit based on these parameters. Your output voltage as well as current is decided based on these parameters. Also, I can say the DC side, another quantity is your the PD. PD is nothing but it is a multiplication of these two quantities. So, we have also the DC side completely, these four variables are there, which is nothing but here VD into your ID. Now, if go for the AC side, AC side means network side, I can say what are the various quantities that we can have, and those can also be drawn on the curve, and that will is called the AC variables are. So, the first one is your apparent power. This is your S of the complex here value. We can also separately have the real power P, we can have a reactive power Q, that AC side. We can have the power factor, we can have the phase current. So, these are basically the 1, 2, 3, 4, 5 quantities we can draw. No doubt this is depend upon this, these three are related to each other. So, we will see means one converter chart will correspond to your DC variable and another will correspond to your AC side. Although we can draw on the same curve, but it will be very complex, because here we are having so many variables on the same axis, means axis means your VD and ID. So, we can just separate two locus, one is corresponding to chart corresponding to DC variable and another we will see for the AC variables. Again here, as I said, that we are having the two modes, one is less than, one is greater than u, and we are having the two different governing equations, and therefore, we have to have the different curves. Now, let us go for u is less than 60 degree first here, and as I have written that these are the equations here you can see. Now, we can simplify here, we are going to denote this your VD divided by VDO, I am just denoting it as your this VD is we are going to denote here as a Y, because we are representing voltage on this axis, your x axis here. So, instead of writing VD here, I am just writing here the VDO, basically it is nothing but it is the per unit value. We are dividing the voltage by the rated value with or without alpha delay. So, here it will be coming 0 to 1 or that is the value. So, it is per unit. So, here similarly this side also we are just dividing ID divided by your IS3, it is denoted as X. So, once you are going to do this too, now you can find what we are getting. We are from this governing equation we are going to have 2y from here, because VD divided by VDO is your y and 2 is here. So, 2y is equal to your cos alpha here plus your cos delta. From this we are going to have x means here your cos alpha minus cos delta. From these two we can eliminate this delta first. So, we will have the relation between x y corresponding to delta alpha, and here just you subtract here. So, we are going to have 2y minus x is equal to your 2 cos delta. Yeah. If you are subtracting, you are going to get this. If you are adding, this will be cancelled and you are going to get another one. Means this we are going to have y is equal to your cos delta minus x by 2. This is equation corresponding between x and y, and this is your delta plus 6 here because this is going this side. If you are going to add this, we are going to have another equation. Means I can write from here, it is your twice y plus x is equal to your 2 cos alpha, or I can say y is equal to cos alpha minus x by 2. We are having another one. Now you can see the slope for this equation is 0.5. This is the positive, this is negative. So let us draw first characteristic, then we will come back for the u, because u can be also obtained from this one by eliminating alpha, because here alpha is also there. So we can just manipulate something here, add it here, and we will find we will getting u term specifically, and then we can have this another characteristic corresponding to this. So for a given value of alpha here, you can draw the characteristic between x and y, and you can have a complete line. Similarly for here. So to draw it here from these two equations, we can just simply draw x and y axis, where this is your y axis, here it is your x axis. Now I want to draw the what will be the characteristic for this. This is no doubt is a straight line having slope 0.5 with the negative, and just we see, let us suppose alpha is 0, or we want to see, we can draw as alpha is equal to, for the different value of alpha, alpha is 0, alpha is 30, alpha is 60, alpha is equal to 90, and so on and so forth. Then we can have the set of parallel lines, because here slope is same, only this constant is changing, means only the intercept and the y axis is going to change, nothing else. So we are going to have the set of parallel lines for the different value of alphas here, and this slope will be the negative. To know this, here we can write here it is 0.25, just mark here 0.5, here 0.75, and here it is 1. This side also we can mark here it is 0.25, here 0.5, here 0.75, here I can say 1. So I am going to draw for the different value of alpha on this axis. Now you can see alpha is equal to 0. First take this expression. If alpha is equal to 0, then we are going to have y is equal to 0.5 x with the negative sign 5, means when x is 0, 1, sorry, alpha is here 0 is 1 minus, right. If x is 0, means we are getting a unity, means we are somewhere starting at this point. Now once x is your 2, it will be 0, means it will be somewhere, it is better we can put x is equal to 1. Once x is equal to 1, it is a 0.5, and the 0.5 here it is somewhere at this point. So we are going to have a characteristic like here, that is your alpha is equal to 0. Means to have a line you require 2 coordinates for given value, and then you can just make it and then you can extend it. So this is your straight line, although it is maybe not so straight, but it is a straight line. We will show again in the clear picture later on. Now I want to go for here alpha is equal to 60. If we are putting alpha 60, here it is 1 by 2, means here we are getting by 2, and now we can just see if x is 0, we are getting 0.5 here, and when x is your unity, it is 0. y axis 0, means we are going to have this point and then we can make it. Now, if you are having two lines, then all these alphas which will be changing from alpha is equal to 0, it can go down, means it will be the parallel line. So, we can say it is your alpha is equal to here 60. So, your alpha is 30, what will be this? If you are going to have alpha, so it is under root 3 by 2 into 0.5 x, and this is value is approximately 0.78. 0.86. So, it will be somewhere here, it will start, it is here somewhere here, and we will find it is a straight line here, alpha is equal to 30. Now, if alpha is 90, this will be 0, and we are going to have a characteristic y is equal to 0.5 x, means it will pass from the origin, and it will be again the parallel to this, and we are going to have this is your alpha is 90. Similarly, we can also draw here 0.25, here 0.5, 0.75, and here unit E. Here means we can have another line here, we can have the here line, all these will be parallel, because this side is your nothing but your inverter operation below this, and this side we are having rectifier operation. So, this side here is alpha 90, this is going to be your alpha, it is what will be the alpha here? No, 180 will be here, here 150, here alpha is equal to 150 will be there. Just put alpha 150 here and you will find what the value you are getting. Or you can see it here, it is alpha 120, it will be not, yeah, it is alpha 120, because if you are putting alpha 120 here, it is 0.5, minus 0.5. So, this is the basically characteristic for a constant alpha. All these lines are parallel, means these lines are, although it is not looking parallel here, but these lines are parallel and a straight line. So, this is called constant alpha curve. On the same axis, now we can draw for this, and this is nothing but it is called constant delta curve, and this slope is positive. So, it will be going up. So, again for this characteristic I can write for the different value of deltas. Here the delta is equal to 0, means we are going to have y is equal to 1 plus 0.5 x. Here delta is equal to 60, I can say y is equal to 0.5 plus 0.5 x. Here delta is equal to 90, here y is equal to your 0.5 x. Here your delta is 120, here y is equal to minus 0.5 plus 0.5 x, and here delta is your 180, here y is equal to your minus 1 plus 0.5 x. So, these are the characteristics for the different value of delta, and here it will be positive. So, we can start from here. So, here if x is 0, we are going to get 1.5 for this value, means your delta is going to be 1.5. Oh, it is 0, then it is 1. So, we are going to start from here, see, and the slope will be just it will be the positive, means your delta here is 0. Now, for this, here x is 0, it is 0.5, means we are having this point here, and when x is your unity, we are going to have 1, means it is we are going to have 1 here, and this characteristic, although it is not good, I think this will be parallel to this one, because all these characteristics are parallel. So, here it is your alpha delta is your 60, when this is your delta is 90, here it is passing through this, means this is 1, it is a 0.5, basically it will be not so correct. Basically, this will be passing through this line here, because this is value, and here it will be the parallel line, I can say. So, this is your delta is 120, here delta is your 180 degree. So, this is the characteristic for the constant delta, and another is corresponding to your constant alpha curve. Similarly, we can derive the expression for the constant u, that is very important, and for that we can use these equations again further to simplify it. Here now what I can do, just use the trigonometric identity. From here you can write it is your twice of cos alpha plus delta by 2 into cosine alpha minus delta, and this alpha minus delta is your u, that is minus u, and cos minus theta is minus cos theta. So, it is u by 2. For this we can again write it is a twice, here it is a sine alpha plus delta by 2, here it will be the negative sign, and then I have to write here a minus b, otherwise if you are not writing here, then it is a b minus a. So, here I can write the sine minus u by 2, a minus b means alpha minus here alpha plus u here this value, and we are getting this minus, and this minus will be cancelled basically. So, I can remove this minus, I can remove this minus here. Now, you can see this value is independent of any alpha here or delta, this is also there. So, we can divide this side, and then we can square and add it. So, what I am going to have here, I can say it is y divided by your cos u by 2, that I can square it, plus here your x by twice sin u by 2 square it is will be equal to unity. Because this 2 I have taken this side, so this 2 is cancelled. So, we are having this 2 sin here divided by x, we are having this, and this is square of this cos square theta plus sin square theta is equal to unity. So, we are having this expression. What is the expression of this? It is not circle, it is a hyperbola, ellipse, yes, because for the circle these should be equal, means this is a, I can say this is a, this is a b. So, here it is your, I can say a, here it is your b. No doubt here the origin will be 0, because this is origin is starting here, there is no minus here. So, it is origin, here also origin. Now, we will see where we are getting this characteristic here for the different value of this. So, now I can write here a is your 2 sin u by 2, and here b is your cos u by 2. This is the basically the distance from the origin from 1/2, and here the a again you see here this is your origin, this is your x. So, this will be giving your a, and this side it will be your b. Now, if u is 0, if u is 0, what we are getting? B is equal to 1, a is equal to, this is 0, this is 1. So, it will be 0 means your this value is a is 0, because I said here this is 0 means you are here, and b is unity means you are going to have this straight line. So, we are going to have for u is equal to 0, this is 1 means this is your this b here, and both the side here it will be here, means we are having this, and this is called your u is equal to 0. Okay. Now, if your u is your 60 degree, Now, you can see once angle is increasing, this value is decreasing, this value is increasing. It is very obvious here. If u is your 60 degree, because that is the limiting point here. So, what we are going to get A for u is equal to 60 degree, here it is a unity, because it is a sin 30 here, and sin 30 is half multiplied by 2 is unity. This side we are going to have B is your the cos 30, that is under root 3 by 2, that is your 0.866. Means for the u is equal to 60, we are getting somewhere value here, even though this is a 2.5 is difference. So, it is 8.6 I think somewhere here. So, and similarly we are going to here, and this is your unity, means we are going to have a characteristic touching here u, and it is coming here like this. This is your u is equal to 60. Now, once your u is reducing, we are not going beyond, because these equations are only valid when your u is less than 60. So, this curve is the limiting curve, means you are operating for u is less than 60, you are inside only, you cannot go beyond this, because for the outside we will have the another equation here, and we will see how the characteristic will change. So, it is u is 0 and u is 60. Intermediately, if you are using u is equal to 30, what you are going to have, this is your u 15 degree, this value will reduce slightly than 1, but it will be more than u is equal to 60. So, means your characteristic here somewhere it is going to be here on the top, it is increasing, but this value will be decreasing. So, we are going to have our here for maybe u is equal to here 30 degree. If you are going to again reduce this, so this will be B will be increasing slightly, and we will be having like this. Here it is u corresponding to your 15 degree. If you are going to have u is equal to 45 degree, it will be slightly less here, and we are going to have here that is u is equal to 45 degree. So, this is the characteristic which we are getting. Now, you can see this is our boundary limit, because these characteristics, even though that is valid, but it will not go beyond, we have to stop here within this constraint, because the governing condition for your delta u etc. in this zone only. We derived all these things based on this. So, your characteristic now lying only between this for u is less than 60. For u more than 60, we will see we are landing somewhere else. Basically, we will be coming outside, but this alpha and delta will be changed, because here we will see the slope of characteristic is also going to change. Now, on this scale itself, if you want to draw the power, this the DC power, here the DC power, as I said, it is a PD. For constant DC power, it is your VD into ID. So, if you want to write in this per unit here, because we are dividing by VDO here and ISC3 here, so I can say it is a PD prime I am writing. So, PD prime it is a per unit value, here it is your x into y, and this is nothing but it is a equation of your, what is this? Is a parabola or hyperbola? Hyperbola. It is hyperbola. So, what will happen here? For the positive, both positive here it will be positive, for one positive here it will be, or one negative it will be negative. So, in this characteristic it will be nothing but it is just like an inverse equation. Here I can say y is equal to some constant PD here prime divided by x, it is an inverse equation. So, we are going to have the different value of this here, and we are going to have this here all this for the positive side. Similarly, we can have our negative side for the different value of p. Now, you will see if your p is increasing, means your y, for given value of this p is increasing, y will increase, means your the power here is starting here, it is your p prime d is increasing, this curve is going away. When p is 0 means you are again here this straight line, because you can see if p is 0 here, either one of the things is 0 or both are 0. So, it will be on that axis. So, it will be like this, either this side and this side, which is undefined. Now, let us go for another side, and to be very clear, you see this graph which is drawn very nicely. Means what I draw here is the similar, thus we are having here, these are the delta constant delta curve, these slopes are the constant alpha curves, and these are our u constant u curve, and here u is your, is looking there, is a u is 60, and this is the boundary where we have to work for this mode of operation. Power is not drawn here, but it is clear that we are having this type of ellipse for the u and the straight line for alpha and your delta. Now, let us see if alpha is, we are just going for u is greater than 60, and now we are having the governing equations, these two equations. Now, we have to see the slope and what will be the equation. Now, since we are drawing on the same scale, our assumption of x prime, that is on the here the per unit on the voltage side and per unit current is not going to change. So, still we are assuming here our Vd divided by Vdo is your y, and I up d upon is3 is your x. So, with this assumption, we can write our equation here. You will see here we are going to have, it is a twice y is equal to under root 3, here your cos alpha prime plus cos delta prime. We know that alpha prime, it is nothing but alpha minus 30, and delta prime is your delta plus 30. Already we have derived this equation. Corresponding to this, here see under root 3 term is only missing. So, I can write here under root 3 is not there. So, we are having x is under root 3 cos alpha minus here cos delta prime. Okay. So, here under root 3, because normally for 3-4 wall conduction mode, voltage reduced drastically and current increased drastically because you short circuit. So, this is the equation, and based on that again, sorry, here it will be prime, and then we can again derive the equation for the constant alpha prime, constant delta prime, and then we also draw for your u characteristic as well in this region, because now u is also changing, and that will be drawn from here. Now, we can use the similar way here. We can add and we can subtract, and we will get the expression for your constant alpha prime and the constant delta prime. Here you can see this the constants, just add it here. If you are adding, you are getting twice I plus x is equal to your under root 3 cos alpha prime, and that will be 2 times. Means we are having your y is equal to under root 3 cos alpha minus. So, from this equation you can see this is id is equal to is3 by under root 3 cos alpha prime minus cos delta prime. Here this under root 3 will go this side, and this is divided here, means we are getting here under root 3 here, x will be this equation, rather than we are multiplying here under root 3. So, in this case what we have to do, to add or subtract, we have to first divide under root 3 here, and then we have to add or subtract. So, this equation again I can change here, and this we are going to have here under root 3 terms here. Now, we can just here add it. So, we are going to have 2y over under root 3 plus under root 3 x. Here we are going to get cos alpha prime, or I can say here y will be equal to here this 2 is cancelled, under root 3 cos alpha prime minus here it is your 3 by 2 x. So, this is one equation corresponding to alpha prime, and then if you are going to subtract this, you are going to get this equation, you will get this equation simply. So, this equation will be your y is equal to under root 3 cos delta prime plus 3 by 2 x. So, just here subtract and you will get this expression for the constant delta prime here. From these two equations you can see here the slope is changed and here the coefficient is also going to change. Due to this slope change, now if it is a negative, it is more negative, and once it is a positive, it is more positive. So, to draw the characteristic here again, we are going to have, again I can draw here rather than the graph. I think this is a more straight line I can draw on this. So, this is your x, here this is your y, and now to have this we want to see where we are going to get this alpha prime, means intercept I want to calculate, means where it is going to be 0, where it is going to be x axis cut and where is your y axis cut. So, for this, if let us take alpha is equal to 30 degree first. For the alpha is equal to 30 degree here, this will be your unity because this alpha prime is alpha minus 30. So, it is unity. We are getting the expression here y is equal to under root 3 minus 3 by 2 x. Now, to have this y is equal to 0, what will be your value of x? Two by root 3 is equal to x, that is for y is equal to 0. This value is approximately 1.15, means here earlier we were drawing here if it is I can say 0.5, here 1. So, we are having somewhere here, I think I can expand the axis more. So, we are going to have here 0.5, here it is 1, and now here it will be somewhere it is 1.15. Now, if we are going to another side, when x is 0, we are getting root 3 and that is your, this is your 0.5, this is 1, I think it will not come, this is 0.5, here it is 1, here it is 1.73 or something. So, we are getting here the expression, this is your, that is your alpha is equal to 30 degree corresponding to your u is greater than 60. Once I am drawing again the expression here, that was your y cos alpha minus 0.5 x. I want to draw again alpha is equal to 30 because that was u is less than 30. This expression was valid when alpha is u is less than 60 degree. So, alpha is equal to 30. Let us see what we are getting. This value is alpha 30 is under root 3 by 2 minus 0.5 x. Now, once x is 0 here, we are getting somewhere value 0.86 somewhere here, 66, and for another value we want, this is value for x is equal to 0, and once I want y is equal to 0 here. So, it will be root 3 and this will be root 3 means somewhere here 1.73 here, this is 1, so it is 1.5, it is approximately correct. So, what is going to happen here? We are just drawing, this is here and this is the intersection point, means this is corresponding to alpha here 30 and this expression is corresponding to your alpha 30 far more than this your value. Now we will see what is the value here at this point intersection. This both characteristics are matching when your u is 60 degree. So, this point corresponds to your u is equal to 60, and here it was your u is equal to 60 in this zone. No, not 60. Here it was 60, then it will be not 0, because this characteristic in the previous one for u is equal to 60. What was this? No, I want for the delta.
Delta 90, sir.
Delta it will be 90. Yeah. Because u 60 means delta 90. So, it is no doubt is delta 90, u is equal to 60, and delta 90 was following here. Because we got the expression here y is equal to cos delta plus 0.5 x. So, delta 90 is 0, means it will be passing from the 0. So, and we also draw the our characteristic which was following u here, means u is going there. So, if you remember here our u was falling, it's going from this u, because u is 60 here, it will be again the this side also, and we were getting this characteristic for u is equal to 60 degree. Means here at this point 1 we had our alpha is 0, this will be parallel here, this is alpha is equal to 0, because alpha 0, then 30, and then we were to 60 degree here the parallel. Now, you can see, and we also draw the u characteristic. So, this point when alpha is cutting your this point, there is some characteristic which is going to be for u corresponding to this here 60 degree. Means we are getting 3 zone, one is corresponding to your alpha, then corresponding to your u, and then corresponding to another characteristic outside. So, here in this, here the same characteristic which I explained here, this is the intercept we calculated, and for this now your actual characteristic for any here alpha is equal to 30 here, now it is not going here, this will be the dashed line because it is outside this 60 degree. So, it will be here this one. So, all these value here it will be basically 90 degree here, and then it will be slope like this. Here it is alpha, alpha cannot be here in this case, you must know this alpha cannot be less than 30 degree. So, this characteristic cannot go here beyond this side. Similarly, we are having the below one also, here in this alpha is your 150 degree. So, we are going to have the characteristic now u is greater than this within this zone only, because beyond this we already draw here characteristic for u is this, means it was u is less than 60. For u is greater than 60, we are only confined to this zone only, and that is you can see very small portion here, and in this one if you are shifting here, there are so many problems because the voltage is reduced drastically, you have to operate in this lower voltage, and current has increased the tremendously value. So, to draw this here again for this given u here, let us see this characteristic. In this characteristic here up to 1, this means it is a u is equal to 60 degree. Means what I did here, the axis is shifted slightly, here you can see u is 55, 50 degree and so on, means here we are having this side. So, this is reduced, and now 1 to 1.5 here it is drawn this side. So, you see here the characteristics almost similar again, only this its the b value and a value is going to change. To have this a and b value, we can again derive from here, from these two equations, we can see what will be the b and what will be a in that zone only. So, this value here alpha is equal to 30, and this is alpha is equal to 150, 120. This value cannot be more than 120 degree. So, in this here we have to draw that we are getting again u corresponding to the different value. To know this again, let us draw what will be the a and b in this case. Similar to this, we can use the trigonometric identity similar to the previous case. We can add, so we can write here 2y over under root 3, here twice of your cos, here alpha prime plus delta prime, it is your alpha plus u, because if you are adding this is cancelled, you are getting alpha plus here alpha plus delta, sorry, it is alpha plus delta by 2 into cos this minus this means this minus this. So, we are having here by 2 of course. So, here alpha minus 30 minus alpha minus u minus 30 degree by 2, because this is your alpha plus u is delta and plus here because minus was outside. So, it is everything is negative, and this value you can see this is cancelled out, and here the minus sign, the cos minus theta is a cos theta. So, we are going to get this value is your u by 2, u plus 60 by 2, because this is u is there and this minus 30 is 60 and u plus 60 by 2 we are getting here. Now, we can, for this one we can write under root 3x is equal to, now I can write, this is a minus sign. So, I can write minus twice sine this plus this means we are having alpha plus delta by 2 into sine alpha minus delta, we are having the same here, and this is your minus u plus 60 by 2. This minus will be cancelled with this minus. So, we can simplify this and we can write here. Now, you can see again this value is independent of alpha or delta. So, we can keep this value here, we can divide this and we can square and add, we are getting unity. So, we are getting here 2y by under root 3, here we are getting twice cos u plus 60 by 2, you square it, plus here we are getting under root 3x by twice sine u plus 60 by 2 and square it, you are going to get unity here again. Now, you can see what we are getting. This is your, in this case I can say b prime, this is your a prime. So, your a prime now is, you can get it is twice under root 3 sine u plus 60 degree by 2, and your b prime, it is your 2 is cancelled, is 1 over under root, no, is under root 3 cos u plus 60 by 2, because this 2 is cancelled and I can write here under root 3, this is your b. So, we are having no doubt the different value of a and a prime and b prime, this axis, but the equation here also we are getting the same as the previous one, only these values are changing, but it is for the constant u, and here you can see u is greater than 60 degree. So, when you are putting the 61, 62, you are going to have the different value and they are going to intercept somewhere, and these are the characteristics we can find it. So, this is basically, it is nothing but it is just related to your the DC quantities. So, from here you can see we are having the, of course, the two modes. One is the here most of the region, just you can see the wider region where we are operating 2, 3, and once u is decreasing, your operation mode is going to be reducing very significantly, very large. And here only you are operating, this voltage is reduced, current is increased, and again the more dense lines are there. So, this is all about your the DC quantities, that is a chart corresponding to the DC constant value of alpha, constant value of u, constant value of PD. We already draw, means it will be nothing, but it will be here, it will be changing, like as I said, it will be here for the different value of P, we can write here in the inverter as well as rectifier operation. Now, another side is that we can go for the network side, and there are so many variables that we have to draw for this one. First one is the displacement power factor, basically displacement factor which is called. There is some difference between the power factor and the displacement power factor. The power factor is basically related with this, the fundamental current, component of current corresponding to the cosine of the angle difference between the fundamental of the voltage and the fundamental of current, the cosine of this. So, that is called the power factor. The displacement factor is basically the RMS value of whatever this current, means power whenever we are calculating this. I can say, if you see in this mode when u was less than 60, we defined the cos alpha was equal to your cos phi. So, this phi was nothing but it was the your power factor. Means if you are writing your PAC, it is under root 3 VL IL cos phi. This IL, it is the total RMS current, it is not the fundamental. If you are writing the here the fundamental here, then this power factor will be the power factor. No, the displacement you have to write complete. It is total RMS value, means including all the harmonics as well. But in the power factor, it will be the here the fundamental component of current, and then corresponding to this will be there. So, we will see, because we derived this expression, and at that time we were using this one, I think. I am sure we are using this. Yeah, it's the reverse one. What?
No, actually cos phi is equal to cos alpha plus cos delta by 2 when u is less than.
Yeah, for u, but if the ideal condition we define this, when u is 0, we are going to get this, otherwise we will get the by 2, and we will derive this expression for the different value of u as well. Here we are also going to derive this apparent power. Apparent power is your S, that is corresponding to real and reactive power. We are also going to see the active and the reactive powers here, and based on that, if active power is known, then reactive power will be calculated from the apparent power. Apparent power is again nothing but your V line under root 3 here, I line. Already we have derived what will be the RMS value of the current in this your AC side, what is the line to line voltage, because this is directly related to the DC output voltage, and then we are here, it is your S. We know your this PAC power as well. The displacement power factor is defined, so we have to draw for this one characteristic, we will see, and then we also draw the constant current, that is A, IA, and this IA we are again talking about the RMS current. We can have even though different fundamental components also, but we can also draw for here RMS current as well. So, this characteristics we will see on the AC side and the next one, not today, and I will explain again how these equations are, governing equations are derived for all these things, and then we will again on the axis will be not changed, axis will be again the voltage axis here and the current here axis x axis, and we will find the different for the constant value of all these 5 parameters. So, in this lecture basically what we did, we just derived the chart corresponding to the DC variables, that is your alpha, delta, u for both u is equal to 60 degree and u is less than 60 degree and u is greater than 60 degree.